Hello and welcome to our webinar today. My name is Larry Pearson. I'm Vice President of Marketing and Impetus Technologies, and I will be your host for today's webinar on the topic of automate and optimize data warehouse migration to Snowflake. For those of you who may not be familiar with Impetus, we specialize in the area of data warehouse modernization, spend the majority of our time there today, and really, this mission statement that you see on the screen in front of you right now is what we most commonly referred to as single source of truth, the big issue for large corporations today. And the topic that we're addressing, including migration to Snowflake, is one way to build a modern data architecture to help you achieve a single source of truth for your business. Let's take a quick look at the agenda for today. We'll talk first off about cloud migration strategy. As I mentioned, we are spending a significant amount of our time in data warehouse modernization, and in today's marketplace, that means we're heavily involved with cloud strategy and cloud migration. We'll talk about how we're helping our clients achieve their cloud migration objectives, specifically in this case using the Snowflake platform, where we talked about automated workload transformation to Snowflake. We'll be demonstrating that solution. And then as I say, we will close at the end with a live Q&A from our panelists. You'll shortly see a poll showing up there on your screen. The first poll question is, which of the migration objectives seem to be most challenging while migrating to Snowflake? And the options here are effort, cost, and time frame, validation and certification, training, achieving performance SLAs, or other. And again, please do respond to the poll here, and we will share the results of that with you. It'll be open on your screen here for 15 minutes. You can respond to that really at any time. And I'd remind you again to send your questions in as well. Let me introduce my colleagues who are delivering the material here today. The first is Sanjeev Sharma. Sanjeev is a principal architect for Impetus. Prior to his current role, he actually was chief enterprise architect in the Impetus Innovation Lab that conceived, architected, and built the solution that we're talking about today. In his role now as principal architect, he works directly with some of our most complex cloud migrations, and he'll be covering a number of the topics that I just talked about on that agenda. With him also is Barry Tuthill. Barry is Vice President of Field Operations in North America for Impetus, and is directly involved with our prospects and clients, building strategies, doing project assessments, building out return on investment analysis, and then working with our delivery teams to deliver on those goals and objectives. So I'd like right now to turn things over to Barry. Barry, over to you.
Yeah, thanks, Larry, and thanks everyone for joining the webinar today. As Larry had mentioned, I lead field operations here at Impetus, and one of the nice things about my job is I get to talk to a lot of customers about their data strategy. And one thing is very clear that we've seen over the past 12 months is certainly migration to the cloud is a hot topic, but more specifically Snowflake. So lots of customers are interested in leveraging Snowflake in the cloud. So we're going to talk about how the Impetus solutions can help customers get there better, faster, and cheaper. But when we talk about cloud migration strategy, there are some core kind of business issues as well as technical issues we kind of talk to customers about. On the business side, I think first and foremost, the consideration is business as usual. So existing BI operations need to continue to run. They cannot stop despite, looking into changes around architecture in the cloud and migrating data platforms. The existing systems need to continue to run. Next, we find that enterprises are looking at their existing investments and really thinking about how do they leverage those investments, because there's 10 to 20 years of effort and in many cases tens of millions of dollars put into these legacy systems. So it's really not feasible in many cases to rebuild everything from scratch, and nor is it really that logical. So oftentimes we talk to customers about who are thinking about rebuilding. We talk about, are you really are the data changes that your end user needs really changing? Are the reports really changing that you need? And most of the time that answer is no. Then risk management. So migration can be a very risky proposition for a lot of enterprises because it involves a lot of different people, process, and technologies. So in large legacy environments, these migrations can be very quickly become error-prone and complex when done manually, or leveraging point solutions that don't address the full migration spectrum. From a cost and scale perspective, enterprises need to understand the capacity that's needed in their cloud environment to manage and understand cost. The promise of the immediate elasticity of the cloud is very, very enticing for a lot of enterprises, but it doesn't mean the CFO's going to write a blank check to move to the cloud. So those costs need to be clearly understood. And from a scale perspective, believe it or not, we talk to customers daily that don't have a clear view into their legacy data warehouse environment. So it's critical to do an inventory of those legacy workloads, associated dependencies, and really understand the scale of the migration. On the people and process side, so stakeholders need to be enrolled in the new tech stack. Many of your end users and IT teams have allegiances to these legacy technologies, and in many cases for very good reasons, because they've been around for a while and providing significant value over time. But what's critical is that there's no disruption to the end users from a people and process perspective as you look at migration. And then finally, interoperability. I think it's pretty clear that from an enterprise view, vendor lock-in should be avoided. So enterprises should be looking at solutions that have the flexibility to move across the different cloud providers. On the technical side, there are also a lot of different considerations we talk to customers about. Obviously, architecture choices that the enterprise makes will ultimately impact their migration strategy. So we know that enterprises make their architecture decisions for a variety of different reasons based on their business objectives, and there's no kind of one size fits all cloud architecture strategy. But for the most part, we see these decisions being made based on as I mentioned, this desire for interoperability across cloud providers, acceptance of open source options like Spark, performance requirements, the data volumes that need to be processed, the complexity of the queries, cost tolerance, and a slew of other factors that go into architecture. On the performance side, obviously, as we move to the cloud, performance is a huge consideration because we need to make sure that the enterprise is meeting end user SLAs. I think one of the nice things about Snowflake is that ability to handle very stringent performance requirements. So, both from an architectural choice perspective and the performance needs of the enterprise really drives this, what we call a migration blueprint. To build a blueprint first, though, the enterprise really needs to understand and assess what is their current state. So they need to understand, the different queries, the different entities and usage patterns within their platform. They need to understand the interdependencies between ETL and the data warehouse processes, the complexity and capacity requirements of workloads, poor performing or unused workloads. So this, blueprint is absolutely critical. And it also helps drive, the next point, which is around automation. So where can automation come into play. And, I really think, when talking to customers, we need to think beyond just purely code translation. Enterprises need to be thinking about how they handle migration from a holistic perspective, everything from assessment to this blueprint to historical and incremental data migration to code transformation and optimization to validation and execution, the full, migration spectrum. Finally, parallel run. So a lot of enterprises for risk management and compliance reasons require some time period that both platforms need to be running before they can decommission that legacy platform. And this adds additional costs and overhead and needs to be planned up front. So, I think in general, when talking to customers, we see kind of 5 kind of major concerns that pop up pretty consistently. One is, how do we leverage our existing investments? How do we reuse what we've already built, these existing workloads, but also how can we take that and optimize it for, our cloud environment? How do we resolve the, migration as is versus total reengineering dilemma? And, what we, talk to customers a lot about, and I think, we've seen it generally accepted is that, we've created this 60-20-20 rule. And this rule basically, says that, if you look at the enterprise's, data platform environment, 60% of that legacy environment can be migrated as is through, intelligent schema transformation, automation. The other 20% can be migrated in a similar manner, but might also require some sort of additional optimization or performance tuning needs on the target solution. And then, that kind of last 20% really falls into that, re-architect category, whether it's something that wasn't built the right way in the legacy environment, but only 20% really need to be considered from a total reengineering perspective. I think one of the nice things that we have seen with Snowflake within our customers is that middle 20%, that kind of optimization and performance tuning category is much less in Snowflake just due to some of the inherent performance capabilities with that platform. The next, kind of core concern or question is what is the extent of automation possible? There should be a way to cover automation considering all of the different migration steps. And I mentioned, this before, and I'll reiterate it again, not just pure code translation, but being able to look at it from an assessment and blueprinting perspective, being able to do that historical and incremental data migration to the transformation, to the validation and execution. And all of that should be automated. And that's one of the things that I think is very unique to Impetus and our workload transformation solution that Sanjay will be talking about and I'll be demonstrating to you in a little while. Then, the next core concern is around the risk and uncertainty. Manual migration can be very risky and error prone. Also taking a pure code translation approach can be risky because it's missing kind of other key, migration steps. So to reduce that risk and uncertainty, really we need to look at a holistic approach. And then finally, performance and cost. So, we've already talked about performance and meeting end user SLAs as a given. But on the cost side, we find that enterprises really underestimate what it takes to migrate. So this really needs to be planned up front and built into the business case model. A lot of times, we've seen enterprises try to take shortcuts and to just really have a disastrous impact on the migration project in the long run. So moving forward, the typical migration checklist or things that we talk about to customers that are critically important that you need to plan for. One is reuse. So embrace what you already have. use what you've had. You'd be surprised how much you can leverage from your legacy environment as you migrate. Number two, automate. Automate as much as you can to get faster time to value, but it also mitigates risks and minimizes errors, increases the productivity, and ensures quality. Optimize. So use migration as a time to optimize for the cloud, but don't stop there. Continue to optimize to continue to take those performance SLAs to the next level. And finally, certify. So thoroughly validate the data, the queries during the migration process in an iterative and agile manner before you put it into production. Don't do validation as an afterthought. Make sure it's part of your process right from the beginning. So with that, I am going to pass this off to Sanjay Sharma, and he's going to dig into some more of the details around the Impetus workload transformation solution. Take it away, Sanjay.
Thanks, Barry. Good morning, good afternoon, everybody. So now we're talking about how Impetus, the workload transformation solution, can take care of all the concerns and the checklists that Barry was pointing out. So again, from an end-to-end automated migration perspective, we will be covering the entire lifecycle, right from starting from the assessment piece. I'll go into each of these sections in more details. But understanding what needs to be migrated, where it needs to be migrated is really important. Of course, we're talking about migration, so we do have to take care of schema migration. We're talking about data migration. Data migration itself is a bit complex. You have to take care of one-time migrations, and then, of course, incremental migrations. And again, incremental migrations can be a real challenge, given that the system of records might still be on-prem, and there has to be pipeline setup, reconciliation processes, and DevOps process setup to ensure that we have all the incremental pipelines available running in the same way as in the traditional data warehouse environment. Of course, we'll excel at the automation for the workload logic conversion, where we'll convert all existing code base to SnowSQL. Now we're talking about things like Teradata BTIC. We're talking about Netezza or Oracle set procedures or SQL scripts. We're talking about SQL Server T-SQL. We're talking about Greenbelt, Vertica, and so on and so forth for any other data warehouse that you might have, and converting those to Snowflake compliant scripts, whether it is SnowSQL, whether it is Snow JavaScript procedures, which were recently added, or have Python or Spark wrappers available around the converted code, especially for very complicated procedure stuff or things which require system calls and other things. For example, Teradata BTIC having activity counts or error codes and other things, or ETL logic like Informatica or Ab Initio or DataStage, which can also be potentially converted and migrated to a cloud-like environment using a combination of EMR, Spark, or Google Cloud Pro, Dataproc, or Azure Synapse or Azure HD Insights. This is also an opportunity for us to automate some of the DevOps processes. Again, the data warehouse, traditional data warehouse world sometimes does lack those governance and agile processes. So the automation that we bring to the table can also help us identify and set up continuous integration and delivery process. We can, of course, utilize the capabilities available in the native cloud, such as CodeBuild and others. And of course, we can also rely on integrating the DevOps capabilities available as a part of cloud native capabilities into the solution as well. Of course, as Barry was mentioning, the last piece would be validation and certification, ensuring that whatever we have converted and moved to the cloud is working in the same exact way as it was in the traditional environment, and business as usual remain same and the most critical thing. So we'll talk about how the solution helps in automating some of these. We started a 4-step process here, which we kind of mastered over the last 7-8 years while we have been migrating a lot of applications to the cloud. Now, of course, Snowflake does make it easier for us because Snowflake, as such itself, is providing a lot of capabilities around multi-cloud readiness or being performant as far as taking workloads is concerned. But again, the process will tell us some of the gotchas that we have seen in our some large Snowflake implementation and share some of the experiences from there. So the 4-step process that we will take for any migration process is starting with assessment, transform, validate, and execute. I'll go into each of these lifecycle steps in detail. So the assessment piece is one of the most critical pieces where we can assess and profile the existing workloads and be able to identify what workloads should be moved as a part of a staggered or an agile plan. We don't really recommend a big bang ever. So this workload assessment allows us to understand what pieces can be moved in first to Snowflake and then take on the other important business applications on the cloud as well. Another thing that we can identify is create dependency graphs between the various end-to-end use cases. So for example, I can identify what system of records are being used for a specific kind of use case or application and work it through to the end consumption tool or usage, which allows me to clearly figure out if I move, let's say, one schema or a set of cables or one use case or one specific user, how does it relate and impact the other users or application or use case or the consumption itself. So grouping of workloads is really important. Other critical thing that assessment helps us to figure out is around performance. Again, I think Snowflake is really good that it offers autonomous performance management. But again, coming from our experiences, things like clustering keys up in the assessment phase itself does help us reduce the overall time and effort to do it later. So the assessment will figure out the patterns of various entities being used in a analytical process, and then be able to recommend the clustering keys for the same. So once we have identified what workloads should be moved in a phased manner, we can now start transforming those. The transformation automation varies anywhere from 90% and above, where we can convert the existing code base to SnowSQL. Of course, we will have to migrate the data beforehand. We will have to migrate the sort procedures, UDFs, take care of data types. Again, Teradata and some of the data warehouses are really very lenient in terms of case sensitiveness or L trims or R trims, whereas Snowflake, although it offers all capabilities, is somewhat lacking due to the enhancements or enhancements or extensions in the existing traditional data warehouse which have gone beyond SQL. So we will take care of converting and taking care of those UDFs which are not present in Snowflake. And again, they might actually not be in SQL 92 compliant. Now, one important aspect of the tool is to create patterns or extend patterns for the architectural guidelines of a specific enterprise. So not only do we have to take care of architecture in the cloud, security and governance in the cloud, but also ensuring that the best guidelines are being used. So some of the architecture, some of the enterprise architects do lay to be stored, or what would be the data types that are required on a Snowflake environment. It might govern how the ingestion patterns would look like, whether you will be using Snowpipe, whether you'll be using the ETL tool, what workflow manager or scheduler will be using the cloud, whether you'll be using the cloud native DevOps or monitoring capabilities, or whether you'll be realizing and using something that is already being used in enterprise. So there's a lot of permutation and combinations as far as the end-to-end environment is concerned, the production environment is concerned. So the tool has the capability to learn those patterns and then be able to apply those as a part of transformation. The tool does offer some nice features as well, such as query editing, where we can quickly on the screen do a lot of editing for the converted code, and gives us a fine-grained control on what we want to see as a part of the converted code. Now, once the applications have been converted, they are running in the cloud, we have the ingestion pipeline set up, we have the consumption tools and analytical tools set up. The next most important aspect of a migration project is validation. So again, validation is a time-taking process, but here again, the automation tool helps us reduce the time considerably by auto-generating the validation and the reconciliation scripts. So we could actually include reconciliation framework as a part of the code conversion process itself. But the end goal is that once we have migrated everything, we are also giving reports that 100% code is getting validated. We can provide a cell-to-cell matching for data as well as for the query validation. And of course, there will be some discrepancies, especially with respect to, let's say, amount fields might be truncating to 6 or 7 or 9 digits or 2-3 digits in your traditional data warehouse, where Snowflake has other capabilities. So if there are mismatches, we will certainly be able to explain why and what is happening, and of course find pathways to ensure that we are able to take care of model risk management scenarios. As I said, we will be taking care of an end-to-end execution environment with the cloud-ready orchestration execution engine, having an integrated DevOps process. So continuous integration, continuous development process can easily be added to the overall process. And again, this might be new concepts, not available in the traditional data warehouse, but are certainly a value add that somebody can get in as an extra hook while this migration project is happening. We can also help with the setting of the decommissioning methodology, including DR, backup, and other things, which actually are a bit more easier in the cloud, given that cloud is built for 24/7 operations and has a lot of redundancies and other things built from ground up. I did talk about multi-cloud readiness. So again, I think we are riding on Snowflake capability to be ready for almost all clouds, whether it is Google Cloud or Azure Cloud or AWS Cloud. But what we bring to the table is ability to integrate and automate some of the security and governance, where again, as I said earlier, we can use the cloud native security and governance tools and policies and processes, or use the enterprise governed or aligned security and governance policies. I'll summarize all of this together in this nice picture here. We're talking about the enterprise data warehouse on the left-hand side. So you can see Oracle, Teradata, Informatica, Netdata, SQL Server. There are others which are not listed here, but ETL tools can also be taken care of, Ab Initio, Informatica, Data Stage, ODI, and so on and so forth. We'll start with the assessment phase, where we'll look at the query logs. Traditionally, these are query logs, historical query logs. For example, for Teradata, it will be the DBC, PDCR query log. For Oracle, it would be again the historical query logs and so on. And we'll also assess the code, which is the workload. So it again might be Teradata BT, it might be Oracle search procedures, it might be Oracle SQL code, it might be Informatica, Power Center XML, and so forth. And then we start transforming those. So the ingestion and ETL starts happening as a part of either Snowflake or similar tool sets that are again aligned with the architecture team. While the SQL, the search procedures get converted to NoSQL or Snow JavaScript procedures or Spark or Python wrappers, while the scheduling, workflow, the DevOps and other processes are converted into a cloud native or enterprise grade ingestion or scheduler or a workflow setup. As far as validation is concerned, we'll ensure that the data has been validated correctly, and all the SQL that is converted, all the workloads that are getting converted are also getting converted correctly. So in the end, we will end up with a system which is at par as far as functional capability is concerned. We will also ensure that all performance SLAs are being met. But more importantly, now we have the capability to use the cloud additional capability, such as Snowflake's auto scaling capability, scale up and down, where you can literally take care of a lot of budget control. So you don't really have to run your traditional system 24/7 as you would do today, and use Snowflake's capability to reduce your operational costs considerably. And of course, the ability to combine with other sources in the cloud and ability to scale up and down really allows the enterprises to think beyond the current capabilities in data warehouse and go to newer opportunities like machine learning or data science and become more business-centric. I'll hand it over now back to Barry again for a demo of some of the things that we discussed and shared with you. Barry, over to you.
Thanks, Sanjay. Good stuff. Let me share my screen. Hopefully you guys see my screen there. I apologize for the slight technical difficulties here. As Sanjay had mentioned, we go through a 4-step process with our workload transformation tool. So as you can see here, this is the tool itself. All you need is a browser to access the tool. It can be deployed both on-premise and in the cloud. But the first step that we go through is the assessment step. When I logged in, it brought me to a dashboard, and the dashboard just gives me kind of an overview of the different projects that I have running. But what I really wanted to start with is showing you the assessment capabilities. As Sanjay had mentioned, all we need is access to the execution logs from the legacy data warehouse environment to create this type of an analysis. What I'm going to start off with is walking you through this section and starting off with the queries. So within the time period of the execution logs that we received, there was a total of 5,135 queries executed during that time frame. However, only 4,683 of those queries are actually unique queries. So why is that important? That's important because what we're doing here is identifying redundancy in the legacy environment. When we want to plan a migration, we want to eliminate any of that redundancy and only migrate and transform unique queries. The next spot that I'm going to point out here is the query types. And you'll notice that this dashboard here is all drillable. So what we do is bucket all the queries across the different query types. But more importantly, what we look at is the complexity of the queries. Now, I had mentioned before in the presentation, we have this rule of thumb called the 60-20-20 rule, right? And this is where we figure out kind of what queries fall into that 60-20-20 rule. So the more simple complexities, like the 1s, 2s, and 3s, those would fit really into that, first 60% category where we can very confidently, easily automate the transformation process of those. Whereas the higher complexity queries, things that fall into maybe an 8, 9, 10 category, those are things that would probably fit in either the second 20% where we could auto transform it and might need some additional optimization or performance tuning kind of manually, or again, kind of that 10 category might be, hey, this just wasn't built the right way, and let's just re-architect it for the target environment. But this is important because this complexity score really helps us kind of bucket the queries into where they fall into that 60-20-20 rule. And we also look at that from a queries construct perspective. So we bucket the queries into constructs into subqueries, order by, group by, joins, etc., and also apply a complexity score there. Next, we move into entities. So the entities, this is important because what this allows us to do is look at the data being accessed and the tables being used to do a hot and cold type of analysis. Because what we don't want to do is start migrating tables and data over for things that aren't being used today. So this is important for us to take a look at and will allow us to identify those kind of commonly used data and tables versus things that aren't used and really doesn't need to be migrated over. On the entity side, this is also where we look at dependencies. So I'm going to walk you through another screen because one of the common challenges that we talk to customers about is the fact that, hey, these data warehouses are so complex, right? We've got this ETL logic and this enterprise data warehouse logic. It's mixed together. It's a hairball. If I move one thing, I'll break another thing. So it's very complicated for a customer to really understand those dependencies across those things. So what we can do with this tool is actually create a graph matrix of the dependencies. So here, if I look up CSV, for example, I can see all the tables or entities that are dependent on CSV. So this gives you a very nice, easy graphical view across the dependencies across your data warehouse environment. Moving back to the highlight section, again, and just kind of reiterating what we're doing here and the value here is one is, hey, we want to identify redundancy and not migrate redundant queries. We want to identify complexity to figure out what can be auto-transformed to your target environment versus what might need to be re-architected. And on the entity side, do a hot and cold analysis and understand the dependencies across these different processes. Next, let's walk into CPU and I/O utilization, right? But the way we're going to look at this is from an application view. So if I click on the application view, I see all the different applications that are running in my data warehouse environment. And I also see the execution, CPU, and I/O time that these applications are taking up. So when we look at the capacity, what this allows us to do is identify the low-hanging fruit to actually migrate and transform to the new platform. If you're trying to, and this is often very valuable for customers that are trying to avoid a capacity purchase from their legacy world, like they might be at capacity and within the next 3 months, if they don't move some level off, they're going to have to reinvest in that legacy world, which is something that customers just don't want to do today. It also gives insight into capacity planning. So it can help give customers some direction across these different applications of what the capacity needs might need to be in the cloud environment. And finally, I think this also gives value in really determining what types of workloads these applications are running. Are these more ETL and data movement type workloads, or are these more BI and consumption type workloads? And this will help guide customers with understanding what's the optimal cloud service that you can use based on whatever the business and architecture objectives are. You know, we talk to customers that want to do different things potentially, right? Some ETL, they might want to move over to like an Azure Data Factory or an AWS Glue, where some customers are, you know, in the Spark world and want to move more stuff to Spark. Whereas, you know, other clients want to move everything over to Snowflake and move it to like a Snowflake, you know, JavaScript type ETL. You know, the nice thing about, I think, our tooling is that we have the ability to support any one of those target architecture patterns. Moving forward with the assessment, you can see that we, you know, we're looking, the system comes with a number of recommendations out of the box. You know, what we're looking at here is the complexity here, where we're almost, you know, kind of pre-building for you that 60-20-20 rule, right? So 3,125 of those queries fall into a, you know, 0 to 3 complexity level. So very confident that we'll be able to auto-transform that. The second category, 20%, might be this 4 to 7, where it's 211, where we might want to look at that, where there might be some performance tuning or optimization that needs to be done. And you can see a number of other recommendations that come out with the engine itself. So this supplements the assessment process that we have, because we go beyond just what the tool does, and obviously we need to interview customers, interview the various you know, stakeholders of BI to really get a clear picture of, you know, what the business SLAs are and things of that nature, so we can create what is the output of an assessment, which is that transformation blueprint and project plan that tells the customer, okay, this is how we're going to get you to point A to point P. And also, you know, through this process, we can work with the customer to create that future state, that optimized future state architecture. So that's a high-level view of the assessment. What I want to go over as well is, now that we've done an assessment and we know what we want to migrate, what do we do then? Well, the nice thing about this tool is everything, you know, after you assess your legacy environment, all that data is actionable, so that we can immediately go ahead and create a migration and transformation pipeline. In this case, I'm going to show you an Oracle to Snowflake demonstration or pipeline that's been executed. We go through 5 different steps. We've got a migration step, a translation step, an execution step, and 2 data validation steps. Here's visually what this pipeline looks like. And you can kind of picture, you know, based on this, like what it takes to create a pipeline. It's very, very easy. Like if I went into the edit design mode, right, it's a simple process of creating or moving these different operations over to this canvas. So for example, if I wanted to add a query validation step, I simply just add, you know, drag and drop that over, connect the dots, and that's really how you create a pipeline. This has already been pre-built for me. It's been executed. So I'm just going to walk you through each step now. But I think it's important to understand is migration isn't a thing that customers are going to be doing forever. So a lot of times our customers don't create these pipelines on their own. It's the Impetus team will come in, will configure these pipelines for our customers, and in most cases run the end-to-end transformation project from assessment to, you know, moving it over to the Snowflake environment. So this is, you know, again, what a pipeline looks like and how you create it. Let's look into the different steps of that pipeline and ultimately the output of each one of those steps. So that first step was migration. So if I go into this migration step, bear with me as the system's running, we see that we've moved over 9 tables, right? And it's been successful and completed. We see the table name, right? And the source and target rows, and we see that those things are matching. So we're getting even some validation here that even in the migration, the data migration, that's all been done successfully. Now, if customers already have a data migration framework or strategy in place, that's fine. We can integrate with that framework. So don't think that you have to use the way we migrate the data. The next step is this translation step. And I think this is really where things kind of get pretty interesting, and it gets into some of the things that Sanjay had mentioned, right, where we have this engine that can automatically convert these Oracle SQL queries into queries that are ready to be run by Snowflake or SnowSQL, right? And you know, we've got a number of examples here. I'm going to walk you through one example just that kind of highlights some of the intelligence, if you will, that is inherent with the engine as far as what we're doing and how we're converting certain things. So this is purely just the SQL query component. I'm going to go into the PL SQL, the more procedural stuff, in just a second. But if we look at this last query here, we see that it's an update query. But we see in the original Oracle query, we've got this customer underscore ID thing, right? And that wouldn't work in Snowflake. In Snowflake, it needs to look like this, right? So we've built this UDFs and all of this capability within our transformation engine to identify these queries and the things within the queries that need to be transformed to Snowflake in a certain way, and we do that in an automated way. Similarly, if we look at this sysdate, right? Well, in Snowflake, when this was created, there was no such thing as sysdate in Snowflake, but would need to be transformed to where is it? Current date, right here. So the engine is doing this in an automated way. Now, you think about what it takes. I mean, this is a pretty simple query, so there's a lot more complex examples. But think about an individual or some sort of large systems integrator having to go through each and every query, thousands of queries, and having to do this manually. It's a tedious and error-prone process that we're applying automation to. Let's jump into the package, kind of the total, executable package, if you will, which includes those SQL queries, but also includes the procedural things. So this is the executable package that's ready to be run against Snowflake, right? If I go down here to show you a quick example of one of these conversions here. For example, this select count PL SQL code. Well, this is the original query. To run in a Snowflake JavaScript world, it needs to look like this, right? So again, this has been auto-transformed. All the intelligence to know what to do with this select statement from a procedural perspective is auto-transformed to what needs to run in a Snowflake JavaScript perspective. Similarly, here's another example. This is a conversion of an else-if, of PL SQL else-if code to Snowflake JavaScript code, right? So this is the type of automation, as Sanjay had mentioned, we're right around 90% automated conversion, right? So again, in these large enterprises that are looking to move over to Snowflake that have tens of thousands to hundreds of thousands of queries, we're able to help drive significant acceleration, not just in that code transformation process, but also in the end-to-end life cycle of all the critical things that need to happen in these projects. Again, from assessment to the transformation process, to validation, to execution. So that, the next step really, besides the data validation step, is really this execution step where it goes and can be automatically executed against Snowflake. So we're really using this tool to help accelerate a, seemingly a very manual, tedious process, but also allowing, there's human intervention involved in this process. So there's human checks and balances to ensure that, these projects are moving forward successfully. So with that, that's all I had to share from a demonstration perspective. Impetus team, you can take over controls and go back to the slide deck.
Barry and Sanjay, thank you for the very comprehensive view of the process and the tool that we wanted to share with our audience today. If our operations team could close the polling now, I'd be happy to share the results of that polling with our audience. I would also remind you that this is a good time to finalize any questions that you may have, because just following this poll, we will open up the webinar to the Q&A portion. So you should see the results of the poll here on your screen momentarily. My ops team is telling me it will be here a couple more minutes. There we go. So now you can see the results of that here. Effort time and time frame, not surprisingly, almost 70% of you said that that is your chief objective. And hopefully you can see ways that the tool you saw today can help improve and reduce the ROI, reduce the time frame and the effort and so forth. Secondly is a broad category of other. 4% were concerned about training. So thank you for participating in our poll. We will move now to the Q&A portion. And let me just check in with our ops team and see what we have by way of questions that have come in. The first question here is, how does your solution help avoid cloud vendor lock-in? Who would like to take that one?
Oh, okay. Yeah, I think, and Sanjay, jump in and provide your feedback as well. I think, certainly there's a number of ways that we avoid lock-in. One is, it really depends from an architectural perspective what an enterprise might want to do, and kind of where Snowflake fits into the picture. We see architecture patterns where enterprises want to do a lot of the heavy lifting, the ETL and data preparation type work in Spark, right? So you can, so you can use native Spark code, Google run it on Dataproc or, on S3 in AWS or, Databricks in Azure. And it's basically your Spark code that is interoperable across these different cloud providers. So that's one way. And then, Snowflake is inherently interoperable across the different providers. So once you've moved to Snowflake, you have the flexibility to, if you've migrated everything from an ETL to consumption perspective over to Snowflake, you can then, shift that environment to any of those cloud providers as well. Sanjay, anything you want to add there?
No, I think you covered that, Barry.
Okay, great. The next question then that we have says, does the solution support migrations for other than Teradata and Oracle?
Of course, yes, we support. We support Greenplum, Vertica, Oracle, and all of the major kind of, I always call them the common cast of characters from a legacy data warehouse perspective. Netezza, all of those guys are fully supported.
Okay, great. The next question that we have says, what are the benefits going from conventional star schema data warehouse and multi-dim or tabular semantic model over to Snowflake or similar big data warehouse? Sanjay, maybe you want to take that.
Yes, Larry. So I think this is actually a good question and kind of a confusion with respect to Snowflake. So Snowflake as a data warehouse in the cloud does not really constrain ourselves to having a Snowflake schema or to a conventional star schema or a multi-dimensional or tabular semantic model. So Snowflake is pretty flexible and offers any kind of data warehouse model. Of course, there are advantages and disadvantages of going from a star schema to Snowflake and others, but I think again, as I said, Snowflake is not constrained to a Snowflake. You can actually use the best of what you have today and reuse some of it in the best possible way in the cloud.
Okay, great. Thank you, Sanjay. The next question says, does the data need to be moved to Snowflake to take advantage of it? Can we take advantage of the strong analytical capabilities using the existing source schema? Sanjay, maybe you want to take that one.
Yes. Again, I think, interesting question. So I think the way Snowflake really performs well and is able to provide on-demand capability on the cloud where you can control your cost for the work that you use or the consumption that you use, it is important that you have the data available as a part of Snowflake. So yeah, I think if you want to utilize the best capabilities of Snowflake, whether with autonomous performance and control on cost and budget, then we need to move to the data to Snowflake.
Excellent, Sanjay. Here's one more for you. It says, what is the underlying technology specifically for ongoing data load from source systems to Snowflake?
So again, one of very important questions. So Snowflake actually comes with a lot of capabilities like Snowpipe. So I think as a part of the Impetus workload solution, we actually take your mload or fast load or SQL loader, other kind of scripts, convert it into Snowpipe. We could also take existing ETL tools that might be being used for ingestion, such as Informatica or Administrative Data Stage, and others, to also convert into Snowpipe-like environment. But we do have customers saying that they do want to reuse their existing toolset. So today, tools like Informatica and Talent and others are also adding support for Snowflake natively. So as far as underlying technology is concerned, Snowflake is pretty flexible, and that's where our automation tool helps us identify what will work best for your environment, given that such ingestions should have reconciliation information, it should have secure data transfer, and other things that might be needed. So yeah, in the end, the underlying technology is pretty flexible. We can use the right one that you are aligned with, or we can use something that we can recommend and works the best for keeping your costs and costs lower and covering all governance and security aspects.
Excellent. Thank you, Sanjay. We do have other questions here. They will be answered and sent out to everyone using email. You'll see on the right-hand portion of your screen right now a couple of things. And the first is a second poll. That second poll says, would you be interested in a deep dive of the product as shown in the webinar? And if you respond there, we'll be sure to follow up with you and schedule a one-on-one deep dive of the product. And obviously that gives you and us the opportunity to tailor that more to your specific environment and some of the concerns that you may have. Secondly, from a user experience point of view, would ask you to be sure to respond to this second poll question which says, please rate your webinar experience experience from 1 to 5, with 5 being the highest. And there is an opportunity here to type any feedback or comment that you may have about the material, the content, the delivery, or the user experience today. And again, we read and value every one of those. Lastly, if you want more information beyond, maybe you're not ready for a deep dive, but you do have other questions and you'd like to get, have us get in contact with you, there's also a lot of information on our website at www.impetus.com, or you can reach us at inquiry@impetus.com. So I thank you again today. Take a few minutes before you sign off to rate our webinar, respond to this second poll question, whether you want a deep dive of the product or not. And other than that, I thank you for your time and have a great remainder of your day.